Hey everybody, today we're doing a few more antidifferentiation examples. These are going to be a little bit more tricky than the ones we saw in our introductory video last time, but not nearly so bad as some of the ones we'll see in Calculus 2. So we're going to do three problems. Each one of them is going to represent an important idea when we're doing antidifferentiation. So even though these are specific problems, they'll give us some general insight as we go through. In the first two cases, we just have to rewrite our functions before we can antidifferentiate. 3 over the square root of x is 3x to the negative 1/2. And this is helpful because I know how to antidifferentiate x to a power. I raise up the power, so it'll be x to the 1/2. And I divide by that new power. Dividing by a half is multiplying by 2. I also know that coefficient of 3 is just going to sort of come along for the ride. So I can antidifferentiate x to the negative 1/2 and multiply the answer by 3. Overall, I get 3 times 2x to the 1/2 plus c, or 6 root x plus c. In the second case, we have a product of polynomials. And it's important to recognize that we cannot just antidifferentiate the pieces. There is no product rule for antiderivatives. You got to FOIL this out first. So first outside, inside last. Now we have a polynomial, and we can antidifferentiate this the same way. Look at each of the terms separately, raise the power by 1, and then divide by that new power. So we get 2 times 1/4 x to the 4th plus 1/3 x to the 3rd plus 4 times 1/2 x squared plus 2x plus c. And we simplify that to get that final answer. Don't forget the plus c. That's an arbitrary constant. It's what tells you that you have the most general antiderivative possible. The third one's a little different. H of x equals sine of 5x. So here we are going to use the fact that antidifferentiation is the reverse process of differentiation. We're going to make some guesses at what we need to differentiate to get this thing. So what kind of function will I differentiate to get sine of 5x? Well, it's going to be some kind of cosine, because the derivative of cosine is negative sine. And in particular, it should be a cosine of 5x, because I know when I differentiate a trig function, the argument, the inside, doesn't change. I'm also going to throw a negative sign in front and do negative cosine of 5x, because again, when I differentiate a cosine, I get a negative sign. So my first guess is negative cosine 5x. I have to check that. I differentiate it, and I get 5 sine of 5x. That factor of 5 in front comes from a chain rule. Derivative of the outside function, sine of 5x, times the derivative of the inside function, 5x. So I'm off from what I wanted by a factor of 5. How do I get rid of that factor of 5? I start by taking my function times a fifth. Now the 5 is going to cancel the 1/5. So overall, my second guess is going to be h of x equals negative 1/5 cosine of 5x. Let's check it. Now when I differentiate, the 5 that comes from the chain rule multiplies by the 1/5 and cancels. Overall, I get sine of 5x, which is just what I wanted. So that negative 1/5 cosine of 5x is an antiderivative. Of course, we need the most general antiderivative. That's why I'm adding the plus c on the end. Then I know that I have found every possible antiderivative for sine of 5x.